Welcome back, Calcsters. Sorry we had such a short assignment last night. The good news is today we'll start a new lesson and hopefully I'll be able to give you more than 5. All right, let's check out the assignment. We had some AP problems. Now, just because they're in that green background does not make them any harder. In fact, I would say with the multiple choice, I think they're a little bit easier, but that can be misleading. Maybe they're not really. So let's look. We'll just go through them real quick, and at least one of them, I assume we'll work number 5, but let's knock it out. On number 1, we are trying to, lost my train of thought, or my spot. Find the dimensions with the largest area that's inscribed somewhere. I think we did a problem just like that yesterday. What did you guys get for the base? 2 root 3, which meant delta was your answer? Fantastic. Delta is correct. On 2, we have a closed aluminum can. It's a cylinder. Here's its volume, and we're looking to try to minimize the amount of aluminum. What's the height that you found? Or what letter did you choose would also be acceptable? Should we look at this one? Okay, so you are correct, just so you know. Yep, but let's check it out. So we'll work through this problem here, and let's see. Anybody get an answer? Or how many of you guys got an answer, rather? A couple of you. What letter did you guys have, just out of curiosity? H. What do you mean H? 16 over 4. Okay. Like 16 by 4? Or just none of these answers? $16 over 4 is 2, 4, right? Oh, so it'd be B? Okay. All right. So let's dig in. Let's see which one it winds up being. And I was trying to figure out why I wouldn't turn here, but that makes sense. Okay. You guys have this problem in front of you. I imagine some of you have your books open. Let's just see if we can't figure this guy out. And we'll copy it and we'll look at it. So here we are. We're going to start this lovely optimization problem. And as always, embarrassing because I don't remember how to do it. But that's okay because somebody will. I just cleared algebra on accident. Whoops. Today's word I've never heard before, and it's so awesome, but we'll get there. All right, so we have a closed cylindrical aluminum can, and there's its volume. We're trying to minimize the amount of aluminum used. Now, that's not a very specific statement. If you think about building a can, what are we trying to minimize, actually? The surface area. That's what we're going for. So as we're looking at these, first step when we're trying to solve one of these ugly optimization problems, draw a picture. Now, it doesn't have to be super fancy. I'm going to draw a small cylinder, and I don't know if it's really going to help a ton here, but here's the top of that cylinder, and it's a perfect right cylinder that doesn't flare out anywhere. So it's this. Fantastic. Lovely cylinder. What do I need to put on the cylinder? Okay, so here's a radius. We'll make it look more like an R. And here's the height of this thing. Fantastic. Okay, well, that's a good start. What do we, how do I keep track of what I'm actually doing through this problem? If I rephrase that, how do I begin writing the stuff that I'm after? Specific language is what I'm really looking for, though. The primary equation. So for this, I know we've already answered it, but I'm going to make us answer it again. What is it that we're trying to optimize, minimize specifically? Not R and H, not quite. The surface area. So I'm going to write this as A. Now, you could call it SA if you wanted it to be specifically with surface area, but I think A is just fine. How do you find the area, the surface area of this guy? Louder, because I hear you saying, love it. 2 pi r squared from what? The top and bottom. There's 2 circles there. Okay, so 2 pi r squared. Love it. Plus, when I unfold or unroll this, this is a rectangle, and its width is what? Say it again. So I would say that's its height, but I'll take that as well. So the height times whatever the other measurement was going to be, though. Circumference. And what's circumference of a circle? Okay. So this is actually going to bug me. I'm going to write this a different way. 2 pi r h is a much more natural way. Okay. What don't I, and I assume you either, like about this primary equation? I did not mark Angel, so let me fix my attendance real quick. What? You say she's sitting there? She's sick. Okay, yeah. I just wanted to make sure that, okay. I thought you were trying to gaslight me, like very not trickily. What's wrong with my primary? That's the question we're on. So? Why? So, kind of. I'll take because it's easier. And sorry to just like good on you for answering. I like that answer. If we try to differentiate it now, we have to do it implicitly, and we need a bunch more information. So that's going to just be rough. I agree. It's because it's easier. What do you want to get rid of then? Let's try to get rid of h. And theoretically, we should be able to write it with an r instead, right? So I have my lovely primary equation. When I'm doing this extra stuff to try to find this other variable, what do we call this equation? Hey, it's our secondary equation. Love it. Well, I need a way to get rid of h, but I'm stuck like always. The volume. How do you find the volume of a cylinder? Love it. Pi r squared h. And our lovely cylinder has which volume? 16 pi. I'm going to do some ... Can we solve this for h? Just little talking. I'm going to divide both sides by pi, right? And then I'm going to divide by r squared. And I think we're just going to get 16 over r squared. Cool. So nothing crazy happens here. H is 16 over r squared. Now what? Plug it in. Now, when I write this next line, I assume like you mean here, I'm pretty sure. What am I going to call my next line? Like I can call it the true primary if I want to, but I'm much more concerned with if you don't want to have to write that true primary every time, there's a notational choice that we can make that says this is exactly the true primary. What was the whole point of doing this? One more time. To plug into the primary so I get an equation in one variable, right? Now, if I wanted to say this is now going to be an equation in one variable, which variable is it? If I don't ever write the argument of this function and I don't like pick out what it is, this works just as well to say, here's my true primary. I don't like, I mean, it's easier for me to follow on my end if you guys show me like, here's my true primary. But if you commit to using this, as soon as I see that you've written this with a single variable and you're now at a point where you can differentiate it, I'm feeling pretty good about this. Cool. So our true primary, let's see, it is 2 pi r squared plus, help me clean this up a little bit. And we'll take 2 small steps, and I'll just take a bunch of small steps. I lied. What am I plugging in for h? Okay, and should we differentiate it now, or should we try to clean it up a little bit? Good choice. 2 pi r squared. What does this other piece of it turn into? 32 pi over r. We now have a true primary function, and we have a way to calculate the area only based on the radius. We're trying to minimize it. Now, whether it's a minimum or a maximum, it's going to happen at the what's. So I heard somebody say zeros. I like that. I heard the other word too. If we start with zeros, we're going to say the zeros of the, no, not the first function. You're close though. The first derivative. Okay, let's find those critical numbers. Do you want to do it together or do you want to do it on your own? Did everybody already do it, I guess, is a bigger question. Before we kick forward, if you struggled with this problem, because it looked like there was a few people that did, have we reached the part where you struggled already? Where was the part that you struggled, if we've already reached it? get into the true primary. Okay, what did you try? Okay. So that's fair. It's always going to be a fine line of whether or not they give you the formula. Like, I think it's reasonable to say, let's all be able to say what the volume of a cylinder is. A cone, I'm less comfortable with. A sphere, like those sorts of things, I'll probably give the equation, but we'll start dealing with spheres and stuff here in the next chapter anyway. So it'll also be fresh. Okay, if we have this, let's find A prime. And if you've already done this problem, awesome. Is the derivative the easy part of it? Can I just do it then without talking through it since we're, okay. I think it's 4 pi r minus 32 pi over r squared. Agree? Okay, looking at this, if you have them, awesome. If you don't, awesome. I want us, and you rather, to find me the critical numbers. And I'm just going to give you a moment. I'll pause it. If you already have them, double check them. If you don't have them yet, find them. If you have them and you don't, and you double check and you're good, check to see if your neighbors need help. Like, we can all help. Cool. I'll give us like 60 seconds here to get critical numbers and then our next step. 2, do I need to show the algebra to get here? Okay. So we now have a choice to make. Are there any other critical numbers just before I move on? I disagree. Let me rephrase that. There's another critical number, but it's garbage for this problem. Where do critical numbers happen? The zeros of the derivative or where it's undefined. Are there any values of r that break my derivative? 0. It makes me divide by 0, right? Why am I not even going to bother including it? Why is that a garbage answer? If I challenge you guys to make a radius, or a cylinder, I'm sorry, of radius 0, or of no radius, can you? No, like that doesn't even make sense, right? Like it's outside of our domain here. Okay, so we have our critical number, decision time. I need to decide if this is a minimum or a maximum, and I'm sorry that I didn't go to green for this, as I said I was going to. How are we going to decide if this is a minimum or a maximum? Second derivative, that seems reasonable. If we didn't want to do second derivative, do we have to? How do I answer the min and max question with first derivatives? Put them on a number line, right? We just check to see if it changes. So second derivative, hook it up. It's 4 pi plus 32 pi over r, 64 pi over r cubed. Am I right? 64 pi? Feels like that's what it's going to be. Somebody second that. What is this always going to be? Positive. Whoever said it, love it. So check it out. Here we are. We can plug it in, and it's good practice to show that we're actually doing it. A double prime of, what's our critical number we're checking? 2. And I'm not actually going to evaluate it, but I do know for sure that it's something. Implies that there's a what at that critical number? Minimum. Remind me again, just with your hands realistically, how do I convince you that it's a minimum if the second derivative is positive? Love that. Lobster claw straight up. It's this, right? That's what positive concavity means. Critical number, it's a minimum. Awesome. Are we done with the problem? We're so close. We were asked for the dimensions, right? Now, at this point, I'm going to argue that maybe we are done with the problem. And we'll see, because on the multiple choice stuff, always good practice. Like, we could finish the rest of the problem, and it's really going to bug me if we don't, but we probably won't realistically. And here's why. What did we just find that the radius needs to be? 2. Which answers obviously are not correct then? C is out and D is out, right? So it's one of these two. So we have to do a little bit more thought, but we don't have to write our like wordy answer with it because it's a multiple choice. If I plug in r equals 2, what's the height? 16 over 2 squared. 16 over 4 is 4. Which answer did we just 100% commit to? Leanne, nice job. It is Bravo. Aren't these fun? I can see you're smiling. You agree. All right. 3 and 4. Delta and alpha. Rafa stopped in this morning to ask about this one because it's a great question. Ellipses, we did not hit a ton of. I don't know if you guys did conic sections in Algebra 2. I don't recall. Do you ever remember dealing with the directrix of a parabola and all that good stuff? I know we didn't do it last year in pre-calc. You might have done it a little bit in Algebra 2. If not, that's okay. This one, I do have a little picture up. It's an ellipse, so it's kind of like an oval, and it's centered around the origin. Just like we see with circles, we have H and K. There's an H and K here, but if they don't include it, what was H and what was K? So just like before, it's our center of our lovely ellipse. So without even knowing it, as long as I know it's an oval, which they tell me, and if you didn't know that an ellipse was an oval, that's fair, but now you do. Here's the picture that we have. Now, should we work this one together? At least start it together? Because I want you guys to come to this conclusion as well, rather than what Rafa and I came to a few minutes ago or an hour ago. All right. So I'm just going to do a really lazy sketch of this because that's how we're going to approach these. I'm going to draw an oval, and I'm not going to put any thought into it other than it's an oval that's around the origin. Now, we could spend time and get a better picture than this, but it doesn't really matter. What's nice about this function, and it's this one, we're trying to inscribe a what in here? We need a rectangle, and the sides are going to be parallel to the x and y axis. So that makes it really handy. I am going to draw a slightly nicer one just so it is a little bit easier to think of. Now, we're going to draw on some old ideas that we don't have to talk about it, but it's a good place to review it. Do you ever remember talking about a function that is even or odd? And the symmetry that associates with them. Even and odd functions. The language is probably familiar, but I'm going to present them up on the board. I'll put them up here. I'm going to show you the two different possibilities just as a refresher. In either case, if we're checking for even or odd, we begin with f of negative x. And there's only two possibilities. If it is the exact same as f, this is even. And if it's the exact opposite of f, it's odd. Now, because I'm looking at this, the x that I have in here gets squared, right? Does it matter if I put in an x or a negative x then? So this is going to be an even function, which means we have y-axis symmetry. And we're going to use that to our advantage here in just a moment. Now, looking at this, I'm going to sketch as best I can this lovely oval. And it's not going to be perfect, but it's much better than it was before, kind of. Golly. Beautiful. Okay, we're going to inscribe a what in here? A rectangle. Now, here's the part and the reason that we talked about the even stuff. If I were to draw any arbitrary rectangle, and we'll do it here. I know it has to be vertical and horizontal, and I'm going to draw it like my piece was actually good, and I'll just make the piece after this. There we go. Now it's perfect. Okay, looking at this thing, because my function's even, what's the same as this area? The other side, right? Now, this thing is symmetric. It's going to be. I have 4 little regions that I can identify, and there's at least 4 ways that we can think about this problem. We could do the whole area of everything, right? We can minimize or maximize that area. Could I do just the top also? And then I would just do what with the area at the end? Double it. But then if I do the top, I have to use positive and negative x, and it's that 2x trick that we saw yesterday. Could we find just this area? And then we would do what to get the total area in the end? We just have to times 4. Like, we get all this symmetry at our disposal. Now, I think it's natural for me, at least, I want to do just this one. And there's a reason, and if it's not supernatural and obvious to you right now, I hope it will be. What was weird when we inscribed the rectangle inside the parabola the other day? Something about the x's that got wonky. Yeah, if we pick this x right here, then the width of the whole rectangle is not x, right? It's x and x to make it 2x. Okay, we need, I don't care which way we go, but we do need to commit just as a class. We're going to work this one together. Are we going to do one region and then multiply it by 4? Or are we going to do 2 regions and then multiply it by 2? Or are we just going to do 4 regions and have to deal with the 2's throughout the whole problem? Rafa suggests just first quadrant and then multiply everything by 4. Any opposition? Okay, so here's my challenge for you then. Let's commit to this first part. If I plot this ordered pair, what's the width of this little piece? That's x. And I'm only looking at this. The height of this rectangle in this first little region, how do we find its height? And you may have to look at your book or up on the board because I think you wrote the function. How do we draw the ellipse or graph the ellipse? What's the equation we use? 4x squared. Sorry, one more time. Where's that coming from? You're looking at number 4, Sean. I think it's this, isn't it? Okay. Now, there's something wonky because I don't want to call this 4x squared plus y squared equals 16. What's a more natural choice for this? H is okay, y is better. Now, here's my challenge. If you did the problem, awesome. If you started it and you're doing it differently, awesome. I want to try, let's see if we can do it this way also. If you haven't done it exactly this way, I want you to try. If you have, Rafa, and you feel comfortable with it, I want you to be the helper with me, okay? Cool. Like, and I'm going to trust your judgment. I'll come help you decide if you're comfortable or not. I want you guys to do something for me. You are going to help me set this up. I want a true primary, and if it isn't sufficient, I want a secondary. Sorry, I want a primary and a secondary if that's not sufficient, and then a true primary. We'll meet back up in a minute. I want you guys to start off until we get to the calculus. You're doing the algebra. Cool. Trabaja. So here we are. I'm going to make my first claim. Let's just start right in as if, like, right where I left you. So my primary, what is it on this problem? And if I can bounce over to the book, what are we trying to optimize? The area. Now, the area of this inscribed region. And I know that if I can find just this one, I'll just do it times, like, depending. We're looking for the dimensions or we're looking for the actual area? What is the area? So we're looking for the area in the end. If I'm just going to use this, I'll just make a note here 4 times this in the end. So I'll make a little note so I don't have to carry the 4 through everything. And that way we'll just do one little piece and then we'll quadruple it. So right now with where we're at, how do you find the area of that little rectangle that we just shaded? Good. And what is base times height? It's literally just xy. Like, that's it. Okay? Now, unfortunately, I don't like that there's 2 variables. But there is a lovely secondary equation that was given that's going to help a ton. What's the secondary equation that I can use to rewrite my primary here in one variable? It's this, right? Now, I'm going to trust you guys here real quick. The algebra stuff, if we need to talk through it, you'll be honest and you'll tell me. But I think we can probably all subtract 4x squared and then take the square root. But what you may or may not be able to do is simplify from there, and we should make a decision. So I guess I'll just do it up here. If I have this, y equals the square root, what has to go in front of it? Plus or minus. Now, that is an important thing that happens in, like, everything that we do. It'll matter a ton here as well in the end. But is there anything that simplifies in this? I would take a 4 out of it. Maybe. We'll have to make that decision. The other part I want to care about is if we're doing this and we're only worrying about this part, I really need to know, is this 0? Sorry, is this positive or negative? Positive. If I plug in a 0, I want it to give me a positive number up here because that's my height. So notice I just scribbled out that negative because when we're thinking in this context, we don't need the negative right now. Okay, so here's why. Now, I could write it like this. And before you commit to doing the same, I want us to look and see if we really want to. If I write it like this, what comes out? A 2. Now, in the grand scheme of things, here's kind of my advice. I could write it like this. And I'm going to have to use a chain rule, right? And I just happen to have a constant multiple now. If I didn't write it like this and I just jumped in right here, do I still have to use the chain rule? if I just used this one instead? Is it still the same amount of challenge with my chain rule? If you're not sure, that's okay. I'm going to write this one here, and we can just think about it. I'm going to write it with exponents instead. These two derivatives, is either of them easier or harder than the other? Like this one might be a little bit easier because there's a constant multiple that you don't have to worry about losing. So they're the same, right? They're equivalent. But if it's not going to make the problem any easier, there's really no benefit to doing this. Would you agree? Like maybe later we'll want to if we have to solve it or something. But I think for the time being, we can probably just use this. Okay, so I can now write, and I had my secondary. I'm just going to write it as y equals the square root of 16 minus 4x squared. And now I want to be able to write a singular function, a of x. And it's not terrible. It's what? And that's way too open. Mickey, x is still x. What am I going to put in for y, though? So I'm going to interrupt you real quick because I see you're looking at your page, but you don't have to. We could use this, but we could also just use this. And it doesn't really matter, but I do think that because they're the same difficulty, let's just use the simpler looking one. Here it is. Okay. Well, we have it. Sweet. Now where do we go? Yeah, let's take the derivative. Okay, I'm going to give you a minute. I'm not going to talk through it unless we absolutely need to, but I'm going to give you guys a moment. I want you to find a prime of x and the critical numbers. And then if it's reasonable, a double prime of x, or if it's not reasonable, I want a different approach to getting the min or the max. I'm going to give you guys 2 or 3 minutes, and we'll come back together. Unfortunately, I don't know that we're going to have enough time to really start a new lesson today. I can't find my cue card. Sorry. All right, let's check it out. We're going to clean it up just a little bit, and I'll save some space just to see. Did you get critical numbers out of it first, I guess? So Sean did and Aisha did. What's your claim here just before I do it? Root 2? Okay, so let's just double check that. I want to clean this up a bit. I see a 2 and a 4. So this one automatically is what? 4 times x is 4x squared over the square root of 16 minus 4x squared. And I'm going to use the square root symbol if I'm not actually doing the calc with it because it's a little bit nicer to think about. Okay, plus, what's up? It 100% is. Thank you. Good catch. You just saved us. Plus root 16 minus 4x squared. And you can just shut it down like, I'm sorry, I forgot to shut it down for you, Vicente. Okay. Well, this is kind of awful at this point because I have a fraction adding with a not fraction. Probably want to add them, I would guess. But to add 2 fractions together, we have to have a what? Now, here's the cool part. Can you tell me what the denominator is here right now? Can you tell me what the common denominator should be? It's the square root of 16 minus 4x squared. Now, I'm going to write it down, but if I were doing this problem on my own, and if you were doing this problem on your own or something similar in the future, maybe we wouldn't really need to write this down. And that's an important concept, and I want you guys to think about that for a second. We're going to pause it. The question at hand is, why don't I really need to write this? Like, I'm making a claim that the algebra is so nice here that I love it. Why does Holloway love it? Talk it out real quick. I'm not even going to pause it. There's something so awesome. Rafa said it right away. Louder. If I take 16 minus 4x squared, the square root times itself, the radicals are just gone. I don't have anything to really have to work out here. I'm immediately, because I see that's going to happen, I'm immediately going to go to my next line. Okay, this is going to be negative 4x squared plus what is going to be left over here? 16 minus 4x squared, and that's all over 16 minus 4x squared to the 1/2. Do you prefer 1/2 or square root? Okay. This is much nicer, and there's even something nicer that happens still. I can see that there's going to be some zeros out of this. Something weird happened here. That's not 16x squared, right? I can see, like, I have no idea why this came up as 16x squared. I caught it this time, so we're not going to keep working the wrong problem. I'm going to erase this x squared. It should not be there. I'm going to get rid of it. I would like to say that that was on purpose. You know what? Free will. That was on purpose. So, no, okay, worth a shot. Find me the critical numbers. You say root 2, I think I agree. Negative 8x squared plus 16 is what this turns into. And we'll go one more line, and I'm almost at the bottom here. Negative 8x squared plus 16 over 16 minus 4x squared. When is the numerator 0? Root 2, right? Plus or minus root 2. Now, based on where we started this problem, where do I not care? I don't care about the negative part of it right now. Okay, anywhere else that is critical? 2, how did you get that? The denominator. When the denominator is undefined, right? Or when the denominator is 0, I'm sorry. And I'm just going to check you real quick. We add it, we divide the square root. It's plus or minus 2, right? But the same thing, we're disregarding the negative because we're only working in quadrant 1 right now. Okay, so I have 2 critical numbers. And now we have a decision to make. I need to decide first, let's see if we really do have a decision to make. I have the sneaking suspicion, I haven't looked, but if I wanted to try to trick you guys with a problem, I would make the options for the width of it 2 root 2 and 4 would be the options because those are the critical numbers and it's going to be one of them. I have the sneaking suspicion. Yep, here they are. They got us good. It's one of them, so that's a good sign. We need to decide which one it is, and we're trying to maximize. Do you want second derivative or do you want to use a number line? Like, there's no better answer. This is a pretty reasonable form of a prime to work with. I think a number line is easier than a second derivative. So let's do that. So we have a lovely number line, and which numbers go on this lovely number line? Root 2 and 2. Now, we could put a 0 on there as well, and it could be a number array, realistically. I'm just going to call it a number line still. Now, here's the nice thing. One of these is a root. One of them was undefined. Which one was the root? Root 2 or 2? Root 2 came from the numerator. That's my 0. Would have been a better choice for language there. How many times did that 0 show up at root 2? Remember, it was plus or minus, right? So we had positive root 2 and a negative root 2. How many times do we write positive root 2 as a 0? Once. And that is an odd number of times or an even number of times? Why am I asking that? Holy multiplicity. Pick something, anything, out of these 3 intervals. So I say anything, but let me rephrase. Pick the best thing out of these 2 intervals. Let's find a of 0. Positive up top, positive down low. A prime of 0, I'm sorry. If it's positive here and a positive here, what's the overall sign? Positive, which means my function a is doing what? Increasing or decreasing? Increasing. Root 2 was a 0 of an odd multiplicity. What is it here without even having to check? Now, could we pick something between 2 and root 2? It'd be like 1.5 would do it. 1.414 is root 2. So 1.5, if we wanted to, we could verify that it's negative. Can I use multiplicity here, though? So, Rafa, I disagree, but that's okay. I like your idea. Why can't I use multiplicity? So that's a good thought. But remember, multiplicity is dealing with the zeros of a function. Where did this number come from? Was it the 0? It's the undefined part, right? So multiplicity doesn't apply. Give me an obnoxious number that we can pick over here. 10 billion sounds good to me. Anything bigger, right? Now, I pick obnoxious numbers because if you square 10 billion and multiply it by -8 and add 16, what is it? Negative a billion? I don't even know what that is. Is it a trillion? Let's see, billion is 9, that's 18. I have no idea what that number is. Big. Negative over, if this is a billion, can you even do it? 16 minus 4 times 10 billion squared. It's an imaginary number. Huh. Maybe this function breaks all the way over there for some particular reason. If we look at the graph, does it go forever in the x direction? It doesn't, right? If you look at that lovely ellipse, it only goes so far over because it's an ellipse. We have picked something outside of the domain, and it makes sense that we're undefined. I wanted to try to do it because it's nice. If we look at the graph, can you tell me when y is 0 on this? Like, how far to the right can I actually go? If that's a 0, you just divide by 4 and you take it's at the endpoint, right? It's at 2. Okay. For this, we're not going to be able to check on the other side of it. But I think logically we can probably reason it out. We have found two possibilities, and I'm just going to look at this picture again. I'm either making the claim that this point around root 2 is where the maximum area happens, or all the way over here, where if you try to draw this rectangle, how tall is it going to be? And that's a weird question because it's a weird situation. And I'll redraw it a little bit nicer. I'm only going to draw this half of it. If I try to draw a rectangle from this point, can I have a height? It won't work, right? Because if I try to draw a height, it's going to be tangent to it. I can't do it. It doesn't make sense to even think about it there, just like it doesn't make sense to draw the rectangle of a radius 0. So I think we found it. At this point, and I'm Control-Zing on accident, I think we're pretty good here. Where does the maximum occur? Max area when x equals root 2. Now, we have to be careful with these. And like, we're going way slower through this problem than I normally would, but I hope that it's clicking and it's hitting everywhere. As we look at this, we are trying to find the area of the largest rectangle. What's the width of my rectangle now? If I know x is root 2. So here's the coordinate plane, and we just decided root 2 is this distance, right? So what's the whole width of my rectangle when I inscribe it? So the width is 2 root 2. Okay, so when x equals root 2, the width is 2 root 2. And could we find the height as well? And if we plug in root 2 into this lovely function for x, and I got to look back at the original, if we, all the way back to the original, if we plug in root 2 for x, let's just try it. What's root 2 squared? So we get y squared equals 8, and it's 2 root 2 for the height, right? But what's the real height? If this is 2 root 2 right here, the real height is what? 4 root 2? So if I go all the way back, here's my root, it's 2 root 2. The height is 4 root 2. Can you find this area? 8 times root 2 times root 2. 16. Okay, big moment here. We are hoping and hoping and hoping that 16 is an answer. Oh, thank God. Cool. All right. I want you all to know there's no additional homework this weekend. Additionally, there's no meeting this afternoon. So if you want to come play chess, learn to play chess. 2:45 is when we're going to open it up to here. Go get a Red Bull, bring it back to me. By then, you'll probably be ready to win some chess games against me. Additionally, I want this weekend everybody to remember that none of you, I don't think, are flibbertigibbets. Flibbertigibbet. I've never seen this word. I had to look it up. I didn't believe it was real. This means a fool. None of you are fools. Enjoy your nice, relaxing weekend. Be ready to undo derivatives starting Monday. I want you to finish number 5 if you haven't, and I'll collect it Monday because I forgot to collect it, or because we worked on it. Cool. Peace out. So right now, Miss Sweet, we are missing